Hello everyone, welcome back to our channel Problematical. In the last class, we saw first half of the miscellaneous miscellaneous exercise. Continuing with it, your 10th question. Show that A intersection B is equals to A intersection C need not imply B is equals to C. So here we have to prove that the given condition does not necessarily mean that B is equals to C. The simplest way to do this question is by assuming the values of A, B, and C. So we have to find certain condition in which your A intersection B is equals to A intersection C, but your B is not equals to C. Let's consider the E set to be 1, 2, B as 2, 3. So your A intersection B over here is 2. Now you have to, this is given. So this condition should be true. That means you have to maintain this A intersection B, and this should be equal to A intersection C. That means A intersection C should also be equal to 2. That means the common thing between A and C should be 2. C can be any set. C can be a set type 2, 3. Let's consider the C1. Or C can be 2, 4, 5. Or it can be C3 is equals to 2, 7. Now we are considering three conditions over here. In the first condition, if you consider C1 to be C, then B is equals to C, which means this is a particular example where C is considered as 2, 3. It satisfies the given condition A intersection B is equals to A intersection C, but at the same time your B is equals to C. If you consider C as C2 or C3, you have 2, 4, 5 in C2 and 2 and 3 in B. So C2 is not equals to B, and C3 also 2, 7 is not equals to B, 2, 3. So this is the condition that you use. One condition where your C was equal to B, that is C1, and other conditions where your C is not equal to B. Next, let A and B be sets if A intersection X is equals to B intersection X is equals to 5, and A union X is equals to B union X for some set X, show that A is equals to B. Now, if you go on using solving this question by a standard method, it becomes a very, very lengthy question. So to reduce time and to keep it within the marks limit, a shortcut can be used. That means you can use your distributive law, which is A is equals to A intersection A union X, and B is equals to B intersection B union X. So we'll make use of this to prove the given condition. What is given to you? It's given that A intersection X is equals to B intersection X is equals to 5. If this and this for certain set X. This is your condition 1 which is given, and A union X is equals to B union X. This is the second condition that is given. For some set X, show that A is equals to B. To show that A is equals to B. Now, if you want to show this, you are considering this as your given, as your standard known values. So we know that A is equals to A intersection A union X. Now A union X is given as B union X. So it can be written as A intersection B union X. Now you can open this. Your A is equals to A intersection B union A intersection F X. Now it's also given that A intersection X is equals to 5. So this can be written as A intersection B union 5. This is equals to A intersection B. Therefore, A is equals to A intersection B. This is third. Uniting 5, which is a null set, with any set will give you that other set, because 5 doesn't contain any element. So you're literally adding no other element to A intersection B. Next, let's consider the second condition. We also know that B is equals to B intersection B union X. Now we know that B union X is equals to A union X. So this is B intersection A union X. This is equals to B intersection A union B intersection X. Again, B intersection X is given as phi from condition 1. So this is B intersection A union phi. Again, this will be equal to B intersection A. Now, intersection follows commutative property. So this will be equal to A intersection B. This is your condition, equation 4. From 3 and 4, your RHS of the two equations are equal. Therefore, LHS will also be equal. Therefore, A is equals to B. Next, find sets A, B, and C such that A intersection B, B intersection C, and A intersection C are non-empty sets, and A intersection B intersection C is equals to 5. Now you have to find such sets. Whenever you're supposed to find some sets with certain condition, either you can use the logic, the given conditions, and when the conditions are more than 3, it's always recommended to use a Venn diagram. So your 3 sets are involved. Let's draw 3 sets in the form of circles. So this is your A, B, and C. Now first is find sets A and B such that A intersection B, B intersection C, C intersection A are non-empty sets, and A intersection B intersection C is 5. And this region is A intersection B intersection C. So you're not supposed to have any element over here, but you can have element, but you have to have element in A intersection B, which is this complete region. So amongst this dotted region, you cannot have any element in this portion, but you're supposed to have an element in the whole of A intersection B. So in the above dotted region, you should have an element. Let's consider a few elements over here. This is 1, this is 2. We're considering 2 elements over here. You can consider an element here and an element here. This literally proves you're given what you're asked. You have to find sets A, B, C such that A intersection B here. A intersection B is 1, 2. A intersection C is 3. B intersection C is 4. But we do not have any element which is common in all the 3 sets. So randomly you can consider an element here. It is optional. You can leave it as it is. Even if you do not consider it, it's fine. Now set A. Now you have to write ABC. That means A is the circle. Let's write all the elements that we have considered in A, which is 1, 2, 3, and 5. B can be 1, 4, 2, and 7. C can be 3, 4, 8, and 9. So that's your answer. In a survey of 600 students in a school, 150 students are found to be taking tea, 225 taking coffee, 100 were taking both tea and coffee. How many students were taking neither tea nor coffee? Now, whenever it's written both, we have both dash and dash. So this is equivalent to A intersection B. First, we will assign A and B as 2 sets. A is set of students who drink coffee. It's set of students who drink coffee. B can be set of students who drink tea. So it's given that the total number of students is 600. So number of students in survey, that means universal set, is 600. 150 students are found to be taking tea. So number of B is equals to 150 number of elements in A is 225. One's drinking coffee. 100 drink both. So number of elements in A intersection B is equals to 100. You are supposed to find out the number of students who drink neither tea nor coffee. So neither tea nor coffee means that this is number of students who does not drink either. So it is number of students in A union B complement, or universal set minus A union B. A union B will be students who drink either of two, either tea or coffee. So if either word is used, either A or B, this is union. If it is neither A or A nor B, it is A union B full complement. If it is both, A or B, या फिर A and B, then it is A intersection B. Now that's settled. You are supposed to find A union B full complement. So we know the formula for A union B, that number of elements in A union B will be equal to number of elements in A plus n of B minus n of A intersection B. Now n of A is 225 plus n of B is 150 minus 100. This is equals to 375 minus 100, which is 275. This is number of students who drink at least one of the two, or either A or B. Number of students who drink neither will be equal to number of U minus number of A union B, which is equals to 600 minus 275, which is equals to 325. That's your answer. These are the number of students who drink neither tea nor coffee. Next, in a group of students, 100 students know Hindi, 50 know English, and 25 know both. Each of the students knows either Hindi or English. Again, you have an either or. So let us consider H with the number of students who know Hindi, E with the number of students who know English. I'm not writing the whole statement. You're given that n of H is equals to 100, n of E is equals to 50. 25 know both means n of E intersection H is equals to 25. What are you supposed to calculate? How many students are there in the group, and each of the students knows either Hindi or coffee. No, it's given that each of the student knows either Hindi or coffee, or Hindi or English. So your n of U will be equals to n of E union H. This is given in this statement. N of E union H is equals to n of E plus n of H minus n of E intersection H equals to 100 plus 50 minus 25, which is equals to 125. This is your answer. Next. In a survey of 60 people, it is found that 25 people read newspaper So n of h is a set of people reading newspaper. H 26 read newspaper T. So n of T is equals to 26. 26 read newspaper I. N of I is equals to 26. 9 read both H and I. So n of H intersection I is equals to 9. 11 read both H and T. So n of H intersection T is equals to 11. 8 read both T and I. So n of T intersection I. 3 read all 3 newspapers. N of T intersection H intersection I is equals to 3. Find the number of people who read at least one of the 2 newspapers. Now, when you are supposed to find at least one of the 2 newspapers, you're finding N of A union B union C. Number of people who read exactly one newspaper. Now, this is a big set, so let's solve the first part first. N of T intersection H intersection I will be equal to T union H union I will be equal to N of H plus N of T plus N of I plus N of T intersection H intersection I minus N of H intersection T minus N of H intersection I minus N of T intersection I. This is equals to 25 plus 26 plus 26 plus 9 minus 11 minus 8 minus 3. So this by calculation, you can add up and then subtract the values and you'll end up with 52. So that's your first answer. N of T union H union I. Now let's draw the Venn diagram. In the Venn diagram, we have we can say that this is H, I, and T. That's given that this is 3. There are 3 elements over here. Next, it is given that H intersection I. H intersection I. That means here you can consider that A be the number of elements in this particular part, which read only either H or I. They do not read T. Similarly, let this be B, this be C. This is D, this is E, this is F. Now you're supposed to find out number of students who read exactly one newspaper, which means you're supposed to find the total of D plus E plus F. This is what you're supposed to calculate according to the Venn diagram. So this one, the total value is 52. From the total value, you want to remove A, B, and C. Total value will be D plus all F values. A plus B plus C plus D plus E plus F plus 3 is 52. This we know. Now D plus E plus F is required. So leave it as it is. D plus E plus F. And shift everything on the right hand side. So 52 minus 3 minus A minus B minus C. This is 49 minus of A plus B plus C. Right. Now A in itself is not given, but it is given that H intersection I, this one, H intersection I is 9. So A plus 3 is supposed to be 9. N of H intersection I is equals to 9, which means a plus 3 is equals to 9, which means a is equals to 6. Next, n of h intersection t is equals to b is equals to 11. This is given as b plus 3. Therefore, we can write b as 11 minus 3, which is 8. Next, n of t intersection I is equals to 8. This is c plus 3 from your figure. So c will be equal to 5. So now you can easily write 49 minus 6 plus 8 plus 5. This is equals to 19. What's wrong? We do anything wrong. 1 second. This was 5, 11. 11 plus 8 is 19. Right, that's true. 49 minus, calculating this is 19, which will be equal to 30. So d plus e plus f is equal to 30, which is your final answer. First answer is 52, second answer is 30. Next. In a survey, it is found that 21 people liked product A, 26 liked product B, and 29 liked product C. So you have n of A is equals to 21, n of B is equals to 26, and n of C is equals to 29. If 14 people liked products A and B, n of A intersection B is equals to 14, 12 liked products A and C, n of A intersection C, and 14 people liked product B and C. The intersection C, n of is 14. 8 liked all the three products. A intersection B intersection C is equals to 8. Find how many liked product C only. So product C only means C, and then you have to subtract the other values from it. Let's draw the Venn diagram. A, B, C. Let's name these regions. This is this is a small a, small b, small c, small d, small e, small f, small g. Okay. You have to find how many like products C only. That means you have to find the value of G. G is equals to question mark. What is given to you? How can you obtain G? If you can remove D, E, and F from it, you can obtain G. Or what can you do? What is given to you? If 14 people liked products A and B, 12 people liked products B and C, and this much. So here it's given A intersection B is D plus E. Given to you. A intersection B, right? So B plus E, sorry. A intersection B, which is B plus E, is given. A intersection C, D plus E, and B intersection C, F plus E. And this will be equal to E. Now to get to the value of G, you have to know D, E, and F. E is known to you. You need D and F. So from this equation, you can say D plus E value is 8 is equals to 12, which implies D is equals to 4. And here, your F plus E, F plus 8 is equals to 14, which is equals to, implies your F is equals to Remove 8 from 14. Wow, too tired to calculate. Hold on. 14. That's ridiculous. Okay, 6. If you subtract this, your b plus 8 is equals to 14. Your b value will also be equal to 6. Right. Now what can we do? Number of people who like product C. You already have this value, 29. N of C can be written as D plus E plus F plus G. And this value is given as 29. D value you calculated as 4. Plus E value you got as 8. Plus F is equals to 6. G you're supposed to calculate. So G will be equal to 29 minus 8 plus 4, 12 plus 6, 18. 29 minus 18 will be 11. So there are 11 students who like, what are we doing? Product, who used product C only. This concludes this exercise. Thank you.